Dear students, welcome. We studied in the previous class about remainder theorem. What is that remainder theorem? If Px is a polynomial of degree more than 1, we can divide it by a linear polynomial x minus a, where a is a real number, so that the remainder will become the value of the polynomial at a. From that, we solved some problems without real division. We could find the remainder of the division. Now, in this part, we will discuss about the factor theorem, then factorization using factor theorem, then factorization by splitting the middle term or middle term splitting. Now, first of all, to start with the factor theorem, we have to go to the lesson previously we have studied. What is that? Let's consider this example. Find the remainder when x square minus 3x plus 2 is divided by x minus 2 using remainder theorem. So, in this case, what is our a? Here a is 2, which is a real number. X minus 2 is a linear polynomial. So, by division, we can say that Px is our x square minus 3x plus 2, and x minus 2 is linear polynomial. So, to find the remainder, we can replace x by 2. That is, to evaluate the polynomial for the value of x as 2. So, by replacing x with t, we have p2 equal to 2 square minus 3 into 2 plus 2. 2 square is 4 minus 3 into 2 is 6 plus 2. This gives 4 minus 6 plus 2 is equal to 0. That means the remainder is 0. If remainder is 0, we can express x square minus 3x plus 2 as x minus 2 into some polynomial qx. This shows that x minus 2 is a factor of x square minus 3x plus 2. Here, we could find the factor of a polynomial. From this, we can lead to the factor theorem. What is factor theorem? The factor theorem says if Px is a polynomial of degree n greater than equal to 1 and a is a real number, then first of all, x minus a is a factor of Px if polynomial value at a is equal to 0. And on the other hand, if polynomial value at a is equal to 0, if x minus a is a factor of Px. Here, let's see what is the proof. How to prove it? First, by remainder theorem, Px is equal to x minus a into qx plus pa, as x minus is the linear polynomial, so we can write like this, and remainder is PA. Here x minus a is a here given if PA is equal to 0. Then what happens to this expression? This expression becomes Px is equal to x minus a into qx. Now, in this case, what do we see? We can see that x minus a is a factor of px. That means by taking PA equal to 0, we could prove that x minus a is a factor of px. Now, if we take x minus a is a factor of px, then we can express px in terms of remainder theorem as px equal to x minus a into some quotient polynomial gx for some quotient polynomial gx. Now see, here the x minus a is a factor. So here the remainder is absent. Now put the value of x as a, that we have to find PA. If we replace x by a, what happens? This x minus a becomes a minus a into gx, the quotient polynomial. So a minus a is 0. 0 into this gx gives 0 polynomial, or value of PA is 0. What does it mean? This is our second part, where we had to prove that if x minus is a factor of px, then PA must be 0. Now we can use this to solve some problems. Let's see. Find the value of k if x minus 1 is a factor of px, that is 2x cube plus x square minus kx plus 1. In this case, as x minus 1 is a factor, that means PA must be 0, as the factor theorem says. So we can say that x minus 1 is a factor of px, and this gives p1 equal to 0. And what is p1? We have to replace the value of x as 1. So that gives 2 into 1 cube plus 1 square minus k into 1 plus 1, as it is given earlier. Now if we calculate it, we have 0 in the equation. We have 0 in left side, and in right side, see, 2 into 1 cube gives 2 plus 1 square gives 1. So 2 plus 1 is 3, minus k into 1 gives minus k plus 1, that means 4 minus k. So 0 is equal to 4 minus k. Now by taking minus k to the left side of the equation, we get k is equal to 4. See, by using factor theorem, we can solve such type of problems. Now look at the screen. Here we have another problem. The factorization by middle term splitting. What is that? If the polynomial is of form x square plus lx plus m is a quadratic polynomial, it can have two factors, namely x minus a into x minus b. In that case, what happens? Let's see. Here it is written L is sum of minus a and minus b, and m is ab. How this happens? See, x square plus lx plus m, and let it be equal to x minus a and x minus b. Let these two are the factors of x square plus lx plus m. Why these two polynomials? Here we have two linear polynomials. So product of two linear polynomials always gives a quadratic polynomial. So as the left hand side is a quadratic polynomial, so it must have at best two factors. In this case, if we write like this, this gives x square minus a into x minus ax minus b into x minus bx, and minus a into minus b, that gives plus ab. So just compare. This is equal to x square plus x into minus a minus b plus ab. Now compare these two coefficients of x. If we compare the coefficients of x, then L is coefficient of x in left side, and minus a into minus b is coefficient of x in right side. So we can write L is equal to minus a minus b, and now compare the constant term in left side. Here it is m, and in right side it is ab. So m is equal to ab. So whenever we have the equation of this type, say x square plus 5x plus 6, such type of problem, in this case we always look for two numbers a and b such that the middle term is sum of these two numbers, and m is product of those two numbers. We'll see it in example. Let's see another type of quadratic polynomial. Here we have ax square plus bx plus c. That means the coefficient of x square is some a other than 1. So in its factors we will have the coefficient of x other than 1. So let's take x square plus bx plus c is equal to some px minus r into some qx minus s. If we multiply the two linear polynomials px minus r and qx minus s, we have pq x square minus rqx minus spx plus rs. Now, if we compare, let's write it in its standard form. So plus x into minus rq minus sp plus rs. Now we can see that the coefficient of x is b here. So we can write b is equal to minus rq and minus sp. That means b is sum of two numbers minus rq and minus sp. Then what about ac? See, ac, if we multiply rq into SP minus SP into minus RQ, it gives RQSP. That means this is same as our PQ into RS. This is same as PQ into RS. What is PQ into RS? PQ is, compare, what is PQ? PQ is coefficient of x square in right side, and in left side coefficient of x square is A. So PQ is our A. And what is RS? RS is the constant term, and here the constant term is C. So RS is C. We can write A into C. That means from this what do we conclude? That B is sum of two numbers. We have to find, when splitting the middle term, we have to find two numbers such that sum of those two numbers is B and product of those two numbers is AC. Now using this, we will work out some problems. Now here, factorize x square minus 5x plus 6 by factor theorem. How to factorize it? Let's see. We know that if A is a real number and PA is 0, then x minus A is a factor. We have x square minus 5x plus 6. You see, if we'll get multiply to linear polynomials, we'll get two constant numbers whose product gives 6. So how to get that? We can make it by minus 1 minus 6 pair, by 1 and 6 pair, by 2 and 3 pair, and by minus 2 and minus 3 pair. So we have numbers minus 1, 1, 2, minus 2, 3, minus 3, 6, minus 6. So out of these numbers, if this is Px, then find this value of Px in these points. So if we put the value of P minus 1, then we'll get 1 square minus 5 into 1 plus 1 plus 6, that gives 1 plus 6, 7 minus 5 is equal to 2. So P minus 1 is non-zero, so this cannot be P x minus of minus 1, that means x plus 1 cannot be a factor. Now let's try with 2. P2 gives 2 square minus 5 into 2 plus 6. From this what do we get? From here we have 2 square is 4 minus 5 into 2 is 10 plus 6. So this clearly indicates that the value is 0. So P2 is 0. We know that if PA equal to 0, this implies x minus A is a factor of Px. From this we can say that x minus 2 is a factor of Px. Now see, if the number is 2 and here the number is 6, then what multiplies with 2 gives 6? Obviously 3. So let's try with 3. So P3 is equal to 3 square minus 5 into 3 plus 6. This gives 3 square gives 9 minus 15 plus 6. Obviously, this is 0. So, by factor theorem, x minus 3 is a factor of px. From this, we can write that x square minus px plus 6 is equal to x minus 2 into x minus 3. This is the process in which we use factor theorem to factorize the polynomial. Let's see another way to solve this. How to solve this again? We shall use the splitting of middle term to solve this, and we'll verify whether what we have done is right or wrong. Middle term splitting, as we discussed earlier, this must be sum of two numbers and this is product of those two numbers. So first of all, we have to find the product of two numbers so that it will be 6. So the numbers are 1 into 6, minus 1 into minus 6, minus 2 into minus 3, 2 into 3. So we have 4 pairs of products which results in 6. Now, in which pair the sum is minus 5? Here the sum is 7, here the sum is minus 7, here the sum is minus 5. So, our choice is this one. We will start with this one and the middle term splitting. So, x square minus 5 will be minus 2. So, minus 5x is minus 2x minus 3x plus 6. From the first two terms, we can take x as common. So, x is equal to x minus 2 minus 3 into x minus 2. This gives x minus 2 into x minus 3. As earlier, we have proved this by factor theorem. So, in both the cases, the result is same. Now, see, we have to solve another problem, that is factorize 2x square minus 7x plus 6 by splitting middle term. Two x square minus 7x plus 6. As previously we discussed that we have to choose two numbers such that sum is minus 7 and product is AC, means 2 into 6, that is 12. So we have to find two numbers such that the sum is minus 7 and product is 12. How to do this? The product, if we take, the products are 1 into 12, 2 into 6, 3 into 4, and their negatives. Here the sum is minus 7, so if we take all the positives, no sum will be positive. So we have to take negatives. So in this case, the sum is minus 13. In second case, it is minus 8. In third case, it is minus 7. So this is our choice. We can take minus 3 and minus 4. So we can write 2x square minus 3x minus 4x plus 6. From this, we can take x common from the first two terms, that gives 2x minus 3, and from the next two terms we take minus 2, that gives 2x minus 3. Now here we have taken 2x minus 3 and here also we have 2x minus 3. So taking 2x minus 3 common, we have x minus 2. This is the factor in this case. Now let's see another polynomial. Here it is 2x cube minus 9x square plus 13x minus 6. Clearly this is a cubical polynomial and it is not possible to factorize it by simply splitting the terms. So what to do? Let's try with the factor theorem. How to try? See, we have the polynomial is 2x square minus 2x cube minus 9x square plus 13x minus 6. Now always look for this minus 6. For which cases product of which numbers is minus 6. 1, 2, 3. This is very, start with these numbers. If we put px is this, now p1 is 2 into 1 cube minus 9 into 1 square plus 13 into 1 minus 6. That gives 2 minus 9 plus 13 minus 6. See, 2 plus 13 is 15, minus 9 minus 6 is minus 15. So this is 15 minus 15, that is 0. Now once we get p1 is equal to 0, it is clearly from our factor theorem, we can say that x minus 1 is a factor of px. Now once we get one factor, we can divide it by this factor to get the quotient polynomial. Now let's divide it. Our one factor is x minus 1. Let me write here x minus 1 in bracket to indicate the factor. Now divide 2x cube minus 9x square plus 13x minus 6 by x minus 1. Here the first term of the dividend is 2x cube and the first term of the divisor is x. So how to get the first term of the coefficient, the first term of the quotient polynomial? That is 2x square by x. This gives 2x cube by x, that gives 2x square. So by substituting here 2x square, just multiply 2x square with x gives 2x cube, and 2x square into minus 1 gives minus 2x square. So subtract it. To subtract it, we have to change the signs. Minus 2x cube is 2x cube, minus 2x cube is 0. Minus 9x square plus 2x square gives minus 7x square. Here it is plus 13x and minus 6. Our new dividend is minus 7x square plus 13x minus 6. So to get the second term of the quotient, we have to divide the first term of this dividend, that is minus 7x square, with x. That gives minus 7x. So minus 7x is the second term of the coefficient. So minus 7x into x gives minus 7x square, and minus 7x into minus 1 gives plus 7x. Now change the sign. Minus 7x square plus 7x square is 0. Plus 13x minus 7x gives 6x, and here it is minus 6. Now the time for the third term of the quotient. So new dividend, the first term of the new dividend is 6x. So 6x by x, the first term of the divisor, gives 6. So this is 6 plus 6. So 6 into x gives 6x, and 6 into minus 1 gives minus 6. So by changing the sign, we get 6x minus 6x is 0, minus 6x plus 6x is 0. So this becomes 0. Now we can write this polynomial 2x cube minus 9x square plus 13x minus 6 as the divisor is x minus 1, and 2x square minus 7x plus 6 is the quotient, 0 is the remainder. So x minus 1 and 2x square minus 7x plus 6, these are the factors of 2x cube minus 9x square plus 13x minus 6. So we can write 2x cube minus 9x square plus 13x minus 6 is equal to x minus 1 into 2x square minus 7x plus 6. We can write like this. Now see, if now this 2x square minus 7x plus 6 is a quadratic equation, we have to factorize it. In previous question we have factorized it. Let it do it again. 2x square minus middle term is minus 3x minus 4x plus 6. From this we get x common to get 2x minus 3, and minus 2 common to get 2x minus 3. From this we have 2x minus 3 taking common, now get x minus 2. So here 2x square minus 3x minus 4x plus 6, this is the splitting up of the middle term process. First of all, we find that x minus 1 as the factor using the factor theorem. Now by splitting the middle term, we find the polynomial 2x square minus 7x plus 6. Its factors are 2x minus 3 into x minus 2. So we can write that 2x cube minus 9x square plus 13x minus 6 is equal to x minus 1 into 2x minus 3 into x minus 2. So how many factors are there in this cubical equation? We have 3 factors, namely x minus 1, 2x minus 3, x minus 2. Each of these polynomials are linear polynomials. So whenever a cubical polynomial is there, it can, if its factors exist, then we have 3 linear polynomials or as factors, or a linear polynomial and a quadratic polynomial as factors. Now let's see some questions to use the factor theorem. Here x minus 2 is a factor of which of the following polynomials? Some polynomials are given: 3x square minus 5x minus 2, x square minus x plus 1, minus 5x plus 9, minus 7x to the power 4, 2x to the power 3, minus x minus 6 minus 2x square. Now just by viewing we can simply discard minus 7x 4. If we put the values of x as 2, we will see that the first one, 3x square minus 5x minus 2, will become 0. So x minus 2 is a factor of this one, and 2x cube minus x minus 6 minus 2x square, in this case also if we put the value of x as 2, it will become 0. So these two have x minus 2 as factor. Now which of the following are factors of the polynomial px is equal to 2x cube plus x square minus 13x plus 6? Now if you see 1, 2, 3, minus 3, 1 by 2, etc. Now by just substituting these values in place of x, we will find that for the value 2 this will become 0, and for minus 3 this will become 0, and also for 1 by 2 this will become 0. So this shows just by putting the value of x, we can find the factors of the polynomial. So now this is time to leave. Thank you.